Hey guys, you probably bumped into some of the cool 3D lighthouse maps done in rayshader, and you were probably wondering how you can do the same. Well, in today's tutorial, I'm going to show you how you can do it using global power plant database and then adding lights to your scene with the help of a rayrender and a rayshader. Alright guys, let's kick off another adventure by first of all installing and then loading the packages that we need in this R session. I'm going to go ahead and create here a list called libs, and here I'm going to declare the names of the libraries that we need. The first one is going to be the Terra library, which we will use for dealing, of course, with raster files. The second one will be the geodata library, which is going to help us get the country shapefiles, but also shapefiles for some subnational boundaries if we wish to. Because we're dealing here with shapefiles, we definitely need the asset package, so I'm also loading that one. Tidyverse, we will need this time only for data wrangling, so not for data visualization, because for data visualization we'll be using a rayshader package. So we'll be creating 3D bubble light maps using a rayshader, and finally, last but not least, we'll be using elevator package to easily get any kind of a relief file for any kind of area that we need. Okay, the first thing is to check then if these library scenes are installed. So we're going to go ahead and take this libs list that we just created, and then we're going to go into the row names of already installed packages. All right, and then if some packages are not installed, we need to install them. So what we need to do here is we need to write an if-else statement. So if any of the installed libraries equals false, in other words, if they're not installed, we open this curly brackets and then we simply say, yeah, we need to install .packages, but we don't need all of the packages. We need those from libs that are not among the installed libraries. All right, and then the one final thing here is to also install the dependencies by saying dependencies equals true. Now that we have installed also those packages that we don't have, the very last step is to load these into R. So what we can do is we can apply to this list of libs, we can apply this function a library, which in R is used for loading packages. In today's tutorial, we'll be using Global Power Plant database from the World Resources Institute, and this is a comprehensive open source database of power plants around the world in different types with more than 35,000 power plants, which is quite impressive. The data, however, is not completely fresh. As you can see here, it was last updated in June 2021, and it's not really clear whether this will be again updated, but for the purpose of this tutorial, where I just simply want to show you how you can add light to point coordinates in the scene and then render using rayshader and rayrender, I think it's completely suffices. So the way we will download the data here is you can see this first link called Global Power Plant Database version 1.3.0. So, and then you see next to it this download button. So what you need to do is click right here and then copy a link address. And then we'll next go to R and programmatically download this to our local drive, unzip it, and then load the dataset into R. Right, you hopefully managed to get that URL and paste it here just like I did. You will notice here that the extension is zip, so it's a zip file. Our first thing here is to declare that this is the URL which we'll be using for downloading the global power plant data. So I'm going to call it URL, and I'm going to add double quotation marks around it so that I declare it as a string. Now the second thing is to define the file name, which is going to actually grab the base name from this URL. And the base name from this URL is going to be this global power plant database version 13.zip. Right, so I'm going to do it like this. Now the third thing here is to download, of course. We here use download file. For URL, we simply declare URL. For the destination file, we simply define this file name. So it's going to be downloaded using that file name. And then finally, for the mode, it's going to be the binary mode. All right, once you actually run this whole thing and download this file, which is going to be very small, think like 4 megabytes, what you need to do next is unzip it. Also quite easy, we just simply pass here the file name. Okay, so I downloaded, I unzipped this file. Next thing, I want to show you actually all the files that I have now in my working directory. So I'm just going to go and unlist those files using list those files. So here, what you can see is after I zipped that file, I got also a bunch of these README files and even a PDF or guidelines in PDF. But I'm interested here about this number 3, which is Global Power Plant Database .csv. So this is actually the table that we need. I'm just going to copy this one and pull this back. The second thing I want to do here is I want to load actually this file so that we can see what it entails. So I'm going to call this power plant df, and I'm going to go ahead and do this read.csv, and I'm just going to here paste this name that I have, of course. Okay, so let's actually run this and let's then inspect the first 2 rows so you can see what we're working with here. So again, it's 4 megabytes, a very small one. I'm using here only because I want to show you, you know, how you can use some simple point coordinate data set like this one to create something really nice with these 3D light bubbles. All right, enough talk. I want to show you also what actually this has. Okay, so it has actually quite a lot of fields, and you can notice here it's organized in a wide format, not really perfect. From 2013 until 2019, there are some things like the generation levels. For us, the most important thing, if not the most important one, is this latitude and longitude. So these are the coordinates. So we'll definitely fetch this. What you can also do here is you can choose only for the country you need. So there is also this country, and then there is this ISO3 code that you can also use for filtering. And then there's also primary fuel. So basically this is the type of the power plant. And you can also use this one and filter only certain types. Okay, so in this tutorial, we'll be using all the power plants for a country. And in this specific case, we're going to be doing it for the Netherlands. So our next thing is actually to filter, take only data for the Netherlands, and then also select only a few columns that we need. We don't need all the columns from this data set. So what I'm going to do next is I'm going to call this country power plants df, and then I'm going to use this one power plants df that we just loaded, and then I'm going to use from dplyr. I'm going to be using filter here. So as we said, country, and the ISO3 country for the Netherlands is NLD. So I'm fetching here only the Netherlands, and the final step is I'm going to be fetching only certain columns here, as we said. So I'm going to be selecting here. So in this case, what I need is, well, we can also use primary fuel. You can even take the name, but the first and foremost is the latitude. That's what we need. And the second one that we need is a longitude. Okay, and then we can also use the primary fuel. I'm just going to show you what are actually different types of power plants according to this data set. But essentially, we'll be using all, we will not be discriminating among different power plants. We'll be using all of the power plants. Now, the only reason why I also selected primary fuel here is that I simply now just want to show you what is the breakdown of power plant types in the Netherlands that you can also use for your own project, and then decide if you want to, let's say, filter out certain types of power plants and keep only others. So here is how we're going to do that. Summary, and then we need to turn into a factor this one here within country power plant df, which is called primary fuel. So I'm just going to actually pull this up again so that you can see the results. So as you do this, you will see that according to this data set, which is not the newest one, of course, 5 coal, 12 gas, 1 nuclear, 13 solar, and 40 wind power plant. So again, we'll be showing all of these on our map. It's not that high number, so we can definitely do that. And in order to utilize this properly, this actually data set, we first need to turn it into an SF object. So we want it to be point shapefile. So let's actually create that. Let's call it country power plants, and then instead of df having sf at the end. And then let's use country power plant df, put it into a pipe, and then using SF and then ST as SF, we can actually coerce it into it. We only need to define two things. The first one is the quartz. So the quartz here are, as we defined before, longitude. So this one, of course, this needs to be in double quotation marks. And the second one is latitude. So latitude is. And the second element here is, of course, the coordinates reference system, or CRS. We're gonna just go for the standard one, WGS 84. All right, we have the power plans as point coordinates. The next thing is to get the natural boundaries of the Netherlands and then use that to crop the elevation, digital elevation model for the Netherlands so that we can use it afterwards in rayshader. So in this tutorial, I'll be using geodata to get the national boundaries. I will call them country SF. So geodata has one function which is very convenient. It's called GADM. This one is basically fetches national or subnational boundaries based on the general administrative boundaries of the world. So what you need to provide here are three arguments. The first one is the country name based on the ISO 3 code. As we said before, for the Netherlands, it's NLD. The second one is the level. So because I want a national level, I choose level which equals 0. If you want the next subnational level, the regional level, that would be 1. You want even to go further, you choose maybe 2 or 3. Totally depends on you. But in this case, we want actually the national boundaries. And then the third argument is here the pathway, where you will actually download, because this is essentially what this geodata function does, downloads this. So you need to provide here the working directory so it actually unloads it there. And then the final step, but very important here, is that you need to coerce this into an SF object, because otherwise it does not come as SF object. Now that we have the national boundaries, we can use them to crop the digital elevation model for the Netherlands. So I'm going to actually call this one simply elef as a shorthand for elevation, and then I'm going to use elevator package, and from elevator I'm going to be using get elef raster. So over here what I'm going to say is for locations I will be using this country SF object that we just defined. For the zoom level, because Netherlands is territorially a small country, I'm going to go for 8, and maybe I could even go for a higher, but this increases the level of detail, so the file can also have a too high resolution if you go for too much. So keep that in mind when working on your own country. And then finally, because I want to clip only the locations of the Netherlands, I'm gonna clip the national boundaries of the Netherlands. I'm not going to take the bounding box or anything else. I'm going to say here that the clip should be equals to locations. Because Netherlands is a European country, I'm going to go ahead and reproject it into this Lambert conical coordinates reference system. And if you're looking for the coordinates reference system for your own country of interest, you can just follow this epsg.io websites and type in just a name and search then for it, which will then of course also show you what are the options there as well for a country of interest. Now going back to this one, what we're going to do is, as I said, reproject. So I'm going to create here elef Lambert. I'm going to use this elef that we created. I'm going to put it into a pipe. Then first of all, I'm going to coerce it into a Terra object, Terra Rust spatial Rust object. So that's why I'm doing this one. And then in the second one, I'm going to be using Terra project, and then I'm going to be reprojecting it into this CRS here. And then in order to work with rayshader, we need to of course transform this into a matrix. So I'm going to here create LMAT, a shorthand for elevation matrix, and then I'm going to put this elef Lambert here, place it into a pipe, and then use rayshader and then raster to matrix. Okay, before we proceed forth, I want to do two more transformations. The first one is specific to the Netherlands. As you may know or may not know, big parts of the Netherlands are actually under the sea level, which means that the digital elevation model in a lot of cases is below zero, smaller than zero. I'm going to just do a transformation where I'm going to everything that is below zero, I'm going to simply transform it to zero so that we don't end up in a situation where some parts of the country look weird just because of this. So let's actually do that first. it's quite easy. So we're going to be operating with this element here. And then in R, what you do is when you define a condition here, you open these kind of brackets, and then you say when element is smaller than 0, and then here simply assign 0. So that's the first one. The second one is something that is not really related to specifically Netherlands. It's actually for any country, and I think you should also do it here. And that is wherever this element is actually has no values. So in other words, if it has missing values, and this is because we only crop that part of the Netherlands, we are going to define it as the smallest value. All right, and we are going to do that because what can happen is that some of these power plants may not really sit straight within the boundaries of the Netherlands. They might go a bit off. In that case, rayshader is not going to be able to render these, so it's simply going to fail. So I'm just making sure that I fill out the holes around the Netherlands. All right, so this is how you do it. First of all, you again element define here, and then the condition. So if basically element is NA, in other words, if there are any missing actually values for this one, and then what you say here that you're going to take the minimum value of elements, of course ignoring all the missing values here. Okay, I also want to make sure that I only capture the power plants that are within the national boundaries of the Netherlands. In this specific case, what we have is also some of the power plants that are in the overseas territory of the Netherlands, but our national boundaries are only for the Netherlands proper. So I'm also going to make sure that we only capture those that are within the boundaries. And I would also encourage you to use this one simply to capture also those that are within the boundaries of your own country. So basically filtering in something that might not sit well, and preventing then rayshader from failing with rendering. Okay, so I'm going to call this country points, and then I'm going to use from SF package st intersection, which is going to help us actually decide what sits where. And then I'm going to use this country power plant SF. So these are our power plant coordinate points, and then I'm going to intersect over the national boundaries. The final step is, of course, to transform this into that coordinate structure system that I previously defined. If you didn't define, you don't need to actually transform this. So we are ready to render our scene, and this is simply going to be for now the relief map. And then to this one, we'll be then adding points by rendering them, and finally, when we render the object, we'll also add the lights to these points that we will cast, and then also reveal some of the contours of this relief. So the first thing here I want to do is define height and width. So the height is going to be the number of rows of this element object. And then the width is going to be the number of columns also of this element object. Then we can go ahead and place this element into a pipe. And then the first thing we need to do here is to define the height shade. So we're going to be using height shade from rayshader. Here I'm going to go for a very light gray texture of the relief, because this is not the focus of the tutorial. The focus is definitely on those light bulbs from the global power plants, which are going to cast some of the light over also the relief. So here what we can do is then simply use color ramp palettes and define here, let's say, two values which are very light gray, let's say gray 90 and gray 60. And then also here what we can define is, let's say, the number of colors, but again, not so groundbreaking, not so very important. The next one is to actually define a function that will create the 3D plot. So here we use a rayshader and then plot 3D. So here we need to pass again element. The second one is the z-scale. So this is going to be how big the spikes are going to be, or bumps. So here we can go for let's say 5. Of course, in some countries which are really hilly or mountainous, you might want to actually increase this number so that you don't get like really rugged terrain. The second thing is that I like to turn off the solids grounds around the object. Shadow is equals true, that's fine. But again, we will be depending on the lights themselves. Shadow darkness, this is how actually how strong the shadows are going to be. One, basically they're going to be very, very light. For the background, we can go ahead and for the background have, for example, white color. You can here play and choose something else. Window size. So for the window size, we can go ahead and, for example, use this width and height that we have. So that would be something like this, width and height. But I'm just going to go ahead and use, for example, a fixed one, let's say here. And then some other things that you can also define is the zoom level here. So let's say, for example, 0.65. So somewhere in the middle. Then the degree angle of the scene, let's go for 85 degrees, so very close to 90. And then theta equals 0 means that our that this is not going to be tilted. Now, after you run this code, the scene will be rendered, and you might be noticing that the relief is, of course, pale. Of course, this is because of the color palette that we chose, but fear not, because we will next render the points. And then as we render the object, we'll also add a lights to it, while we will kind of darken out the rest of the map. All right, so let's go back here to the code and let's go ahead and now render the points. So that's going to be our next step. Okay, so to render the points, we first of all need to extract the coordinates from that previously created object, which is called country points. So in order to extract, we need to use st coordinates from the asset package. And here we simply pass country points. Okay, then we need to take long and lat, so or longitude and latitude. So we're going to be using from quarts, and we're going to be using actually a column which is denoted as x, while for lat we'll be using quarts, but we'll be taking here something which is denoted y. So here we get actually a longitude and a latitude. Now we are ready to actually render the points. So for that purpose, we use rayshader once more, then render points. And after we choose this, we actually need to deal with several things. First of all, we need to define here lat, as we did, so it's called lat. We need to define also longitude, so it's called long. We need to choose the extent here. Now, the extent can be several things. It can be an SF file, it can be a raster file. For us, the easiest way is to simply use this LF Lambert that we previously defined. So that's the easiest way. We also need to define the height map so that rayshader knows how to position our points in terms of the altitude. So for that, we can simply use the elevation matrix, and we can paste it here. Now the Z scaled here, I'm just going to go for 1, and that actually works quite fine. So and then the size, of course, here you can choose different sizes. What I'm going to do here is I'm going to go and choose a 5, but within the rendering itself, you will be able to actually choose the point radius. So do not worry if this is not too big or if it's too small. And then finally, what we can do here is we can define color, and I'm going to go for a bit warmer color here. So I'm going to go for something like orange, which is also actually a national color of the Netherlands. So then when you actually run this, you will see that to this pale relief scene, we also added now these orange colors, or orange colors denoting actually all those power plants. Okay, so the time is ripe to finally render our object and add the lights to the scene. So the first thing we will do here is declare here the name of the image that we will be saving here. So I'm just going to call it 3D Power Plant Netherlands.png. And then I'm going to call rayshader and render high quality in specific. So the first thing is to define the file name that we already have here, which is called image name. The second thing is that we want to have the preview as the scene renders. The third is we're going to turn off the lights because we want to have a darker background and then only those power plants shining in the dark. And then we have actually 3 arguments which are related exactly to these render points. The first one is the one that I actually mentioned to you, point radius. Here you can define your points to be actually wider than you had in your scene. So I'm going to go ahead and choose, for example, 7 here. These are not really intuitive, so I cannot translate to you what it means. You really need to, check this in your specific case and see if it works. Of course, it's going to be a lot dependent on the size of your country, but also the density of the points that you're trying to render here. So that's the first one. The second one is related to the point material. This one is actually what is the array render function that you're applying here? And we're applying from rayrender, we're applying a light function. So this is what we wanna have. Now, once you actually define this, there is a third one, which is called points material args or material arguments. So here is the list where you further specify how you want to actually apply this rayrender light. So the first one is the color. And here, we're just going to go ahead and take that orange color that we already defined while rendering the scene. So that's the first one. The second one is the intensity. So intensity here means basically, how strong is this going to be emanating? And the default value is 20. Again, not completely intuitive, but I'm going to go ahead and increase it 3 times to, let's say, for example, 60. You can, of course, play with these things and see what works for you. There is another thing that you can add here, and that what I'm gonna also do is gradient color. So you can also make sure that you're not only using this one, but you can also choose a bit lighter or even darker version of the color, similar color. So I'm gonna go again from a warm color, but it's gonna be this one, which is more yellow. It just to kind of make it disperse as well into this gradient color, this original orange color. Okay, so these are some of the things. Now, because here we're working with light spots, it might happen that the lights are too strong and then they are actually creating some really awkward spots there. To mitigate that, there is something which is called clamp value. And if you choose something that is closer to 0, but still greater than 1, I would say, then you don't need to worry about the lights being too strong, emanating too strong light. So I'm gonna here and choose 2. And then there is another one here, which is called minimal variance. So minimal variance, I'm gonna turn it completely off. Basically, this defines the number of samples and how samples should be. So I'm gonna take the maximum number of samples that I can. And for the sample method, I'm going to use the one of the best quality in rayshader, which is called Sobel. The reason why I'm doing this is because we're working here with lights and we don't know how this is going to pan out. So we're trying to here get the best quality image as possible. So those are the main things. And then there are some other things like, for example, I want to turn off the interactive mode. So that's also one of the things. I also want to do the parallel equals true. So I want to use basically all the possible the multiple cores. And while there are also some other possibilities that you can add here, those are the major ones that I would go with. Alright guys, this is how you make effective 3D light bubble maps using R and a rayshader. In today's tutorial, we used global power plant dataset for our point coordinates, and then with the help of rayshader and rayrender, we added the lights to them and darkened the scene as well. If you're curious how to replicate today's analysis, I've prepared the link to the GitHub repo in the description box below, so do check it out. Feel free to clone it, reuse it, modify it as you see fit. I'm also looking forward to your own projects and how you take this tutorial on a journey across the world. If you have any questions, comments, or just general feedback, feel free to reach out to me here on YouTube, but also on Instagram and X. If you're new to R and you seek to expand your data visualization and geospatial knowledge in R, I prepared a few cool tutorials for you, so do check them out. See you next time.